Let's solve an old quiz question. First read and take note. At 10 HP, 250 volts, 750 RPM DC serial motor. You should know that those information belongs to nameplate and they are rated values. DC serial motor have an efficiency of 85% at full load. Okay, that is again belongs to rated value. You know, efficiency is a function of loading ratio. It has a different curve. At one point it has got a maximum value, but here given a value belonging full load operation. The voltage drops are given as a percentage of applied terminal voltage, and 1 HP is equal to 746 watts. Mechanical losses are neglected. Machine's magnetic circuit will be assumed linear without saturation. Let's take notes what is happening here. There is a DC motor connected serial. It is motor, and then here's the terminal voltage plus and minus. Here's a load current. Here's armature current. Here's field current. All those are equal, as you see. Here's the mechanical output. Possibly here's a mechanical load. Let's remember the labels. On the figure, old terminology is given. With a new terminology, here's A1, A2, and serial 1, serial 2. That is the connection diagram. Let's draw the equivalent circuit. Here you apply a voltage, plus and minus, and then here's the resistance of serial field winding, and then here is a resistor of armature winding, and here is a dependent voltage source, which is EA, armature EMF. That is the equivalent circuit. Here is a Kirchhoff's voltage law. All those currents are equal. That is the equivalent circuit. And some percentage of voltages are given across those elements. Let's define what is being given here. Mechanical output power is given in nameplate 10 HP. Always output power will be given. 1 HP is blah blah. So mechanical output power is equal to 10 times equivalent of 1 HP. So that is the mechanical output power in terms of watts. Terminal voltage is given. Here it is defined. And rated speed is given. Let's say nominal or rated. Both are correct. And full load efficiency is given. Let's say again rated value, nominal value. And some voltage drops. 4.52% of terminal voltage is defined. And you know terminal voltage, so it can easily be calculated here. 11.3 volts across these resistance, and 2% of the applied terminal voltage will drop across serial winding resistance. It is 5 volts. Again, You observe 5 volt here across this element. We have just read the question and calculate the obvious ones. So far we have read this. Motor is operated at rated power. In some questions from here to here, only the one part possibly different. We will read. Let's read step by step and solve. Draw connection diagram, show terminal labels. That is the first thing. We have already drawn here. That is the circuit diagram. That is the equivalent circuit. We have drawn the circuit diagram. We have shown the terminal labels. We have completed the question A. Let's discuss question B. Find input power in kilowatts. We know output power, and for the rated value it is easy. Efficiency is output over input power. Output is mechanical, input is electrical power. Simply write P. Input power is equal to output power, which is mechanical, over efficiency at its rated value. That is the rated input power. So it can easily be calculated. Let's calculate. Input rated power is equal to mechanical rated output over efficiency at nominal conditions. Mechanical output, let me define it here. Okay, that was the mechanical output, and that is the input power. We have calculated. That is, as you see, it is very easy so far. Let's check it out. Here are some answers given. Yes, that's it. In the question C, find load current. Here's a circuitry. You have applied terminal voltage. It draws some load current. And here is some input electric power. And we have just calculated for rated conditions. So electric power is equal to terminal power times the current drawn by the circuit, which is load current. And in the question, load current is asked. So load current is equal to input terminal power over terminal voltage. Let's say rated current, rated input voltage, and that is the rated terminal voltage. Let's calculate. Load nominal, power nominal over terminal voltage. It is just 35.106 amps. That is the current drawn from the power supply. Again, so far it is easy. We got 40 points right now in a few minutes. Let's talk on this. What is array and serial field rheostat? It looks easy because here are some elements called serial field winding. Let's say armature winding. Here's the equivalent circuit. And we know some voltage drops we have already calculated. 5 volt across serial resistance, 11.3 volts across these elements, armature resistance. So voltage difference across armature resistance is equal to armature current times armature resistance. In the question, armature resistance is asked. So armature resistance is equal to voltage difference across armature resistance over armature current. Let's calculate. Ra, armature resistance, is equal to voltage difference across armature resistance over armature current. Ladies and gentlemen, it is equal to field and load current. So load current we have already calculated. It is here. So armature resistance is calculated as 0.322 ohms. It must be a small resistance, so it looks fine. Okay, let's continue for serial winding resistance. Voltage drop across serial field coil is equal to field current times field winding resistance. So serial field winding resistance is equal to voltage drop across serial field winding over field current. You know, all those are equal. So let's calculate. It looks easy. Let me copy and paste it and then change parameters as Rsf, beep, beep, beep. Okay, here it is as Rs, just one letter different. Serial winding resistance is also smaller. It looks fine. Let's check my results. Yes, here they are. We are on the right way. We have completed 20, 40 and 60 points right now. So far it is easy. Find out torque on shaft for the rated conditions. Okay, torque is a mechanical parameter. Here is the motor, here is the shaft supplying some mechanical output in terms of torque and angular speed. So torque is equal to mechanical output over angular speed of the shaft. For the rated conditions, here is the rated power, here is the rated torque, here is the rated speed. Rated angular speed can be calculated as 2 pi n over 60. That is the rated speed. So let's substitute the parameters here and then calculate rated output torque. E, angular speed of the shaft for rated condition is equal to 2 pi rated speed over 60 makes such a radians per second. We have calculated, and torque nominal or rated torque is equal to mechanical rated output power over angular speed of the shaft. So torque can be calculated as 94.984 Newton meters. That's it. As you see, it is easy, radian per second, and that is the rated torque, output torque. Ladies and gentlemen, we got 80 points right now. Let's continue. It gets easy so far, but the last question is a bit tricky and a bit difficult. Calculate terminal voltage for half speed. Here are extra information. Load torque is constant. We have already calculated here. Torque is 94.9 blah blah Newton meters. It is constant at given above conditions. That's the clue. Calculate terminal voltage for half speed. What does it mean? Ladies and gentlemen, here's a motor. It is a serial motor. Here's the voltage source, let's say terminal voltage, an external power supply applied, and then here's a mechanical load having constant load torque, having 94.984 Newton meters. That is the torque load, and it is equal to mechanical output torque under steady state conditions. If there is no speed change, those are equal. Load torque is constant and speed is half of its rated value. Calculate terminal voltage for half speed. That is the full speed. Calculate for the half speed. Ladies and gentlemen, it looks there is a speed control operation. Someone has adjusted voltage, possibly voltage has a decrease, and then possibly output power has some decrease, and then there's a speed drop given 750/2. Oops, I made a mistake here. Here is angular speed in terms of radian per second, but I have written here RPM speed, so take care, they are not equal. And in the question, it is asked that what would be the new terminal voltage to manage such a speed adjustment. You can easily see that on mechanical side, mechanical torque times new angular speed, which is the half of rated speed. That is rated speed, that is half of rated speed, so that is the half of mechanical output power. Remember, full mechanical power can be calculated by a mechanical rated torque times rated speed. That is the mechanical output. In new case, since you have dropped speed at half value, so this guy has a half output power. And then here are some other consumptions. Here's the equivalent circuit. The converted power or armature power is this across this element. Here is an armature resistance consuming some armature copper loss in terms of armature current squared times Ra, and here is Rs, and again the serial field winding consumes serial field copper loss in terms of field current squared times Rsf, and here is the input new terminal voltage and new input power. Possibly, I am not sure if the current is constant. I am not sure yet. You have applied input power, electric power here, and then you have consumed some copper loss in serial field winding. Then you have lost some copper loss in armature coil. Then you have converted power into mechanical power. Then possibly here are mechanical losses, but mechanical losses are neglected, so it is omitted here. Rest of the power will be delivered to load. That is the power flow. So it is equal to terminal voltage times current, new terminal voltage. Those must be new values. Again, all those And we know this. We know half of the output power. Torque is constant at its rated value. Speed is half speed of its rated value. So that is the new mechanical output. New mechanical output makes such a half value of prior power. That is the half of this guy. Let me check it out. Yes, that's it. That is the half of the previous output power, since speed has decreased half of its prior value. We have calculated this new power. We should know current at least. It looks like a power balance problem. We should calculate this and this, that is equal to each other. It is equal to armature EMF times new load current. Let's say load current, new value, IL new. But I'm not sure if there's a change in current. Output power has changed. Input power possibly will change because output has decreased down to half of its prior value, so that must be changed. Let's talk on torque and current relation. Torque in general is equal to an armature coefficient times field times armature current. That is the torque expression induced in armature. If there is no friction, it is equal to mechanical output under mechanical losses neglected. Okay. Now, ladies and gentlemen, we know first one and second one. In both cases, torques are equal, ladies and gentlemen. Load torque is constant at given above conditions. So it is rated torque, mechanical. There's a clue. Mechanical load torque, which is 94 blah blah Newton meters, which is constant during the operation, equal to Ka phi current. What is phi? Phi is a function of field current. Ladies and gentlemen, it is defined here. Machine is assumed linear without saturation. So possibly there is a linear relation, something like that. That is a coefficient, zeta. Okay, field current is equal to load current. So Ka times zeta times load current. And here is armature current, which is equal to load current again. That is the first one. In the second condition, or the condition asked in F, again, left hand side is equal to blah blah. Here's Ka, machine coefficient, armature coefficient, it is constant. Here's a magnetic relation coefficient, it is constant. And here is I load squared. As you see, ladies and gentlemen, left hand sides are equal, coefficients are equal, so old current and new current must be equal. It looks a hidden parameter, but load current new value is equal to load current's old value, which is 35.5 0.106 amps. That is the one of the important parameter to be calculated for the solution. But we have not completed yet. Let's write power balance. Applied input power, losses, and output. So, input power is equal to copper loss in armature, copper loss in field coil, plus mechanical new output, which is the half of its rated value, since there is no mechanical loss. That is motor and no mechanical losses. Okay, Houston, I load squared new value times array plus our serial field plus, I know this guy, 3730. That is the new output power. That is the new input power must be equal to new voltage times new current. New. Houston, that is the old one. We know this. That is the old one. We know this. We have just deduced here, concluded here. So let's calculate input power. New input power is equal to old load current, it is equal, which is rated value, squared times Ra plus our serial field coil resistance plus mechanical new output power, since there are no mechanical losses, and new input power is this. Let me show in decimals. Volts. Ladies and gentlemen, as you know, power across terminal can be written as voltage times current. Here. And take care, current is old value, but voltage is new value, power is new power. Okay, power new over a load current, which is rated value, old value, that will bring out new terminal voltage, which is 122.55 volts. Ladies and gentlemen, to manage speed change, you have adjusted terminal voltage. It was 250 volts in the beginning, and then to decrease speed down to its half value, you decrease terminal voltage down to 122.5 volts. It looks like half of its rated, but ladies and gentlemen, let's check it out. Half of terminal voltage is 125, but it is a bit smaller. There is no linear relation between them. I mean, to decrease output power to the half of its rated value, it doesn't necessarily mean that you should decrease supply voltage to its half value. Please take care. That is the result. Let's check it. Yes, finally, perhaps here will be a different solution method, but the result is the same, as you see. Okay, that's the end of the question. It was easy to have 80 points from this exam, but having full point is a bit tricky and difficult, so you should know many things. You can also find this solution in Turkish in my YouTube playlist.